Artillery has always played an important role in armed conflict since it first appeared on the battlefield. The war between Russia and Ukraine is no exception. While the Russian army is still using the old iron from the Soviet era, the gods of war from the armed forces of Ukraine are skillfully utilizing the American M777, which we will be discussing in today's video. Despite the Ukrainian fighters' extremely effective use of high-tech anti-tank javelins, which provide infantry with unprecedented firepower, towed artillery still remains one of the most vital weapons used on the battlefield. Having already used most of the weapons at its disposal, Ukraine turned to its Western allies for artillery capable of striking a noteworthy blow against the Russian invaders. Among the most coveted options was the M777 or 777, a light 155mm towed howitzer. The development of this field howitzer began back in the 1980s by the armaments divisions of Vickers Shipbuilding and Engineering, headquartered at the industrial English town of Barrow-on-Furness. Following the demonstrations of the prototype, the successful design was brought out by BAE Systems, Global Combat Systems Division of Hattiesburg, Mississippi, and its dull name, the Ultralight Field Howitzer, was changed to the more concise M777. BAE quickly made the decision to Americanize the gun, with the M777 now using about 70% US-made parts, including the gun barrel produced by the Watervliet Arsenal. One of the howitzer's outstanding features is its weight of 9,300 pounds, 41% lighter than its predecessor, the Rock Island Arsenal M198, which weighed over 15,770 pounds. This light weight is mainly due to the use of titanium and aluminum alloy in its design. It also greatly facilitates the transportation, delivery, maintenance, and storage of the M777. For example, the howitzer can easily be carried on the external sling of a Boeing CH-47 Chinook transport helicopter, aboard the legendary Lockheed C-130 Hercules, Boeing C-17 Globemaster III, or the latest Bell Boeing B-22 Osprey convertiplanes. Additionally, this weapon can be towed using FMTV, Family of Medium Tactical Vehicles, and MTVR, Medium Tactical Vehicle Replacement, and some other types of military transport. Christopher Hatch, the LW-155 Deputy Program Manager, said, "One of the M777's extremely valuable features is the ability to quickly travel by helicopter to various places inaccessible to ground transport. This was the perfect solution for Afghanistan, which had many high-mountain forward operating bases, where it would be simply unrealistic to lift the M198. The possibility of more thorough concealment also benefited the M777. In stationary positions, this gives it a noticeable advantage over its brother, the self-propelled M109A6 Paladin, in combat conditions when enemy forces have an airspace advantage. Along with the weight, the requirements for the number of fighters controlling the gun also decreased. Operating the M198 required a crew of 9 people, but with the M777, the minimum artillery crew was almost halved, coming down to only 5 people. The howitzer has high operational capabilities. Its deployment time is less than 3 minutes, its takedown time is about 2 minutes, and an experienced crew can squeeze out a maximum of 7 rounds per minute in intense combat conditions. The standard rate of fire for the M777 is set at 2 rounds per minute. The cannon's barrel serves as a tow bar, and the connecting ring is forged like a muzzle brake protrusion. Today, the M777 uses a towed artillery digitization fire control system similar to the one used by the previously mentioned M109A6 Paladin. Using data from drones, this greatly improves the howitzer's accuracy in targeting and locating. At the same time, we also see in use the Canadian M777C1 modification. Along with the traditional glass and metal sights on mounts, the DGMS, Digital Gun Management System, fire control system with IFCSS, Indirect Fire Control Software Suite components, created by the Italian defense company Leonardo. Although the original version of 777 used a simple optical sighting system, with the advent of new modifications and a digital fire control system, the firing range has improved significantly. Up to 14 miles for conventional M795 projectiles, and up to 25 miles for special M982 Excalibur GPS-guided ammunition. The use of the latter almost doubles the area covered by a single battery, out to about 480 square miles. As part of howitzer testing at the Yuma Proving Ground, 13 of 14 Excalibur rounds fired from up to 15 miles struck within 33 feet of their target. In other words, the probable circular error of the projectiles, or CEP, was no more than 16 feet. In June of 2012, Gulf Battery 2nd Battalion, 11th Marines from Camp Pendleton, California, opened fire on insurgents in Helmand Province, Afghanistan, firing the longest live round of an M982 Excalibur projectile in M777 history, as well as the longest combat shot in the history of the Marine Corps. This once again proved the effectiveness of the howitzer to all those still skeptic. As for the farthest hit with Excalibur ammunition on the U.S. Army side, this took place in Iraq at a range of 19 miles. It was the military glory acquired by the gun in Afghanistan and Iraq that earned it the reputation of the most effective towed howitzer of its kind. However, the most long-range M777 ever created can rightfully be considered the M777 ER modification developed during the ERCA Extended Range Cannon Artillery project, designed to increase the firing range from 19 to 43 miles. The M777 ER has a longer 30-foot, 58 caliber barrel with XM1113 active rocket and XM654 charges, as well as a new automatic projectile loader. The most recent modification of the gun is the M777A2, which received a Block 1A software update, an improved inductive artillery fuse (EPIAFS) Enhanced Portable Inductive Artillery Fuse Setter for compatibility with Excalibur and precision-guided ammunition. The M777A2 exceeded the military's expectations with an impressive average of 880 rounds between system interruptions versus the expected 800 rounds. According to the command, further upgrades on the M777 will make this piece of U.S. artillery even more versatile, reorienting it from the narrow sphere of low-intensity wars to war with any given enemy, including technologically advanced ones. In addition to the United States and Canada, other M777 operators include the armies of India, Australia, and Saudi Arabia. Back in 2010, Brazilian authorities also considered the M777 as one of the potential options to replace the 6 155mm Marine Corps M11 4A1 howitzers, but in the end, they couldn't make a final decision. However, the most notorious use of 155mm howitzers was by fighters within the armed forces of Ukraine during fierce battles with the Russian invaders. U.S. officials have confirmed that an entire batch of 90 guns has been handed over to Ukraine, along with tactical towing vehicles and FMTV trailer vehicles with an armored cab. Another 10 M777s were donated by other allies, 6 by Australia and 4 by Canada. The main difficulty for Ukrainian soldiers in working with these guns was training. As of May 23rd, the media reported that 200 trained soldiers had completed a 6-day course at German bases. Part of this group has now gone to the front, while the remaining ones began to train their comrades. At the same time, the majority of military experts are sincerely surprised at the speed with which these Ukrainian fighters are mastering the supplied weapons. Sometimes it takes 3 times less time than expected time, even during the most operational training. In mid-May, Commander-in-Chief of the Armed Forces of Ukraine, Valery Zaluzhny, demonstrated 155mm howitzers in action, thanking the United States for supporting the country in its fight against the invaders. Artillery strikes, including those from recently arrived M777s, caused enormous damage to the enemy, who was trying to build 4 pontoon bridges across the Seversky Donets, as a result of which about 400 invaders died, numerous tanks and armored vehicles were destroyed, and some were abandoned. Due to their accuracy and power, 777 became an important factor in changing the situation for the better. However, in order to finally kick the invaders out of their native lands for good, Ukraine will need American M142 HIMARS MLRS capable of operating at longer distances. Ukrainian soldiers have repeatedly proved to the whole world their courage in battle. But will Western politicians have enough courage to approve the supply of heavier weapons? That is the main question that remains to be answered. What other weapons do you think Ukraine lacks that could get rid of the Russian invaders once and for all? Share your guesses in the comments below. And if you enjoyed this video, please leave a like and subscribe to the channel for more content just like today's. Thank you, and we'll see you in the next one. Throughout the 20th century, MLRS have been and remain the most widespread type of rocket technology used by ground forces in all kinds of wars and armed conflicts. The best MLRS to date are the American M270 and M142 HIMARS. What kind of animal is this, and why should it become a game changer for the Ukrainian army? We're going to cover that right now. Most of you have probably already seen what modern MLRS look like more than once. Perhaps against a background of these, the first kinds of volley fire platforms, invented back in the day by the Chinese Song dynasty, seem at least somewhat strange today. But in the old days, there was considerable success in raining hundreds of fiery arrows that fell on the heads of these poor fellows who dared to besiege castles. One example of such systems, perfectly preserved as a museum exhibit, is the Hwachcha MLRS, developed in Korea in the 15th century, the name of which literally means fire wagon. It's clear that in comparison with modern-day missile systems that can attack targets at 300 kilometers or more, a volley of arrows at a distance of 300 to 400 paces is just cause for a smirk. However, in reality, a shower of fiery arrows covering the sky is a very menacing sight, reminiscent of a mini-apocalypse. Having played enough with Mysore rockets and Congreve rockets created by the British inventor William Congreve, humanity gradually reached the Katyusha, T-34 Calliope, Stalin Organ, also known as the 8-centimeter Raketen Wildwaffenwerfer, and many other crafts before realizing the importance of a massive transition to modularity. To date, there are two types of MLRs. Those with non-removable, often steel pipes with the option of manual or semi-automatic missile reloading, famous for being undemanding in regards to additional tools for maintenance, or modular MLRs, or those with containers that can be removed from the launcher, quickly replacing them with the same missiles or completely changing them to another type of ammunition. The latter gives commanders much more freedom in the field to solve a wide array of tactical situations using different types of missiles, require minimal reload time, and are easier to upgrade. The undisputed boss among all launchers in the world today, though, is the M270, an armored, self-propelled multiple-launch rocket system developed by American specialists together with colleagues from Great Britain, West Germany, France, and Italy. After a long debate in March 1974, the U.S. Army formed requirements for a new rocket launcher, giving it the name General Support Rocket System, or GSRS. Its main task was to combat enemy air defenses, counter battery fire, and neutralize enemy artillery. The new mount was to have a longer range and sufficient firepower to free up cannon units to support infantry and armored vehicles. As a result of U.S. consultations with NATO allies, who were trying to create a similar system on their own, a decision was made on close cooperation, and the name of the system, GSRS, was replaced by the one more familiar to all of us, MLRS. The actual development began in September 1977 by Boeing and Vought Aerospace, who won their competitive contracts worth $855,000 from 3 competitors. Each of the companies undertook to submit to U.S. Command 3 models for combat vehicles with unguided rockets for further testing at the White Sands Missile Range in New Mexico. Development continued until the 1980s and eventually became a top priority for the Field Artillery School, which considered the installation the most impressive new weapon system. The first production models were introduced in August of 1982, and the first operational M270 battery was formed in March 1983. A few years later, the systems entered, with other things, into service with the ground forces of various armies around the world, and the total number of M270s that left the assembly line by 2003 exceeded 1,300 units. In parallel with this, more than 700,000 missiles of various types were created for them. MLRS M270 self-propelled loading launcher consists of 3 main subsystems: M269 loading launcher module, loader launcher module LLM, the electronic fire control system installed inside it, and the M993 vehicle, a derivative of the Bradley fighting vehicle chassis. The main tactic for the use of such systems was the principle of fire and forget. Since this was, at the time of their creation, the main task was to avoid the vulnerability of friendly forces encountering Soviet counter-battery fire. One M270, firing 12 basic M26 missiles with a range of 32 kilometers, covers an area of 600 square meters with 7,728 projectiles, and the firepower of a single MLRS battery, producing a full salvo of 108 missiles, is equivalent to 33 cannon artillery divisions. The system can also fire containerized MGM-140 ATACMS missiles. Each capsule contains 6 standard missiles or 1 ATACMS guided missiles, since the 2 types of ammunitions cannot be mixed. The LLM holds 2 capsules at the same time, into which rockets are manually loaded using an integrated winch system. All 12 ATACMS missiles can be launched in less than 1 minute, and one M270 firing 12 missiles completely covers 1 square kilometer. A typical missile salvo consists of 3 M270 vehicles, each firing 12 missiles containing 644 M77 grenades. The total release into the enemy area is equivalent to 23,184 grenades. Unfortunately, there were some downsides as well. With a 2% unexploded ordnance ratio, about 400 unexploded projectiles will remain in the area of impact, which can endanger not only friendly troops but also civilians. At the beginning of 2006, the MLRS underwent a global modernization for the use of guided missiles. The first phase of XM31 missile testing was completed in a wild rush in March 2006, since there was a critical need for the use of a unitary guided projectile in combat operations in Iraq. In this regard, Lockheed Martin received a contract to convert existing M30 DPICM GMLRS missiles into the unitary XM31 variant. The use of the M1 GMLRS made the M270 a point-fire artillery system for the first time. With GPS guidance and a single 200-pound high-explosive warhead, these missiles hit their targets accurately with less chance of collateral damage. This opened, among other things, a lot of opportunities for the use of MLRS in urban environments. At the same time, the number of launched missiles also decreased significantly, reducing the logistical load. The M31 was equipped with a dual-mode fuse with pinpoint and delayed detonation options for hitting soft targets and lightly fortified bunkers. The improved version of the projectile, the M31A1, has already received a multi-mode fuse with the possibility of a non-contact air explosion to neutralize enemy personnel. Its height can be adjusted to 9.8 feet or 32.8 feet, and the range of the GMLRS ranges from a minimum of 9.3 miles to 43 miles at Mach 2.5. Over its long years of service, the M270 has been taught to work with two extensive families of ammunition: MFOM, or MLRS family of units, among which are the M26 and its improved versions, M26A1 and M26A2, unguided rockets with a cluster warhead and a firing range of up to 28 miles. The GMLRS M30, which is a 240mm cluster warhead guided missile with a range of over 43 miles. The M28 and M28A1, 227mm reduced range practice rockets. AT2, 227mm cluster rockets for laying mines, and many other modifications of the above ammunition with different ranges. And AFOM, Army TACMS family of munitions, including ATCMS Block 1, tactical missiles with a cluster warhead containing 950 M74 rounds and a firing range of up to 102.5 miles. ATACMS Block 1A, an improved modification of the Block 1A missile with an American Navstar GPS receiver, 275 M74 submunitions, and a firing range of up to 186 miles. ATACMS Block 1A Unitary, tactical missiles with 500-pound HE warhead, inertial guidance system, GPS receiver, and a range of 167.8 miles. ATACMS Block 2 and 2A, tactical missiles with cluster warheads for 13 or 6 aiming BAT submunitions, and a range of up to 87 and 137 miles, respectively. No less impressive is the list of MLRS modifications. To date, there are 9 of them in total. In order to not having to delve into these versions that turned out to be more of an intermediate link or were created for the needs of specific allied states, like the M270 for Britain with reinforced armor to protect the crew, we'll focus on more global ones. M270 the basic version in 1983. M270A1, MLRS version with an improved IFCS, improved fire control system, and an improved ILMS, improved launcher mechanical system, due to which the guidance time was reduced by 85% and the MLRS reload time by 40%. Additionally, a self-diagnostic function that can detect malfunctions in a timely manner has come to be a very important innovation. M270C1, modification with the new UFCS or Universal Fire Control System, developed for HIMARS to replace IFCS. M270D1 received a new computer, positioning devices, GPS antennas, launch control unit, informative displays, and remote control devices. The most recent was the modernization that started just this year, the M270A2 version, which switched to the Common Fire Control System or CFCS, the same for both the M142 and the M270. It features a new engine, transmission, launcher module, and improved IAC, or improved armor cab, capable of protecting the crew not only from small arms, but also from mine explosions. Recently, the Pentagon recognized the 1980s ATACMS developments as obsolete and announced the creation of a new LRPF OTRK, the heart of which will be the Precision Strike Missile, or PRSM, which can also be launched from the fleet of existing American MLRS. In terms of pricing, MLRS has also undergone significant changes. The cost of the basic version of the launcher cost $418,998, but its modern incarnation, the M270A2, will run you $966,589. But even the mighty M270 of the U.S. Army wasn't enough. Along with these in the late 1990s, the United States acquired yet another MLRS, M142 HIMARS. This is a light-wheeled version of the big brother, the M270, with one capsule containing 6 missiles or one MGM-140 ATACMS missile instead of 2, as is the case with the M270. All this awesomeness was installed on the frame of a standard Army 5-ton M1140 truck from the FMTV family and can feed enemies with all types of the previously mentioned AFOM and MFOM family projectiles. As for combat experience, the M270's first battle hardening took place during the Persian Gulf War, when in support of Operation Desert Shield in 1990, 6th Battalion from the 27th Field Artillery Regiment was deployed to Saudi Arabia and played a decisive role in its early defense. A little later, during Operation Desert Storm, this battalion became the first U.S. field artillery unit to open fire on Iraq, providing timely and accurate rocket fire in the theater of operations. During the Desert Storm, 89 M270s were involved. Their first task was to launch 8 ATACMS missiles at Iraqi air defense systems on January 18, 1991. And by February of that same year, the 4th Battalion of the 27th Field Artillery Regiment staged the largest MLRS night fire in history, firing 312 missiles in one sortie. By the end of February that year, another 414 missiles were fired to support ground operations. In total, out of 57,000 artillery rounds fired by the end of this year, 6,000 were MLRS rockets and another 32 were ATACMS. Since then, the M270 has been used in many combat operations, including the invasion of Iraq in 2003. The first use of the GMLRS occurred in 2005 in Iraq, when 2 rockets were fired at Tal Afar at a distance of more than 30 miles and successfully hit insurgent strongholds, killing 48 terrorists. In 2011, the first upgraded MLRS-2 and M31 GMLRS rockets were handed over to the German Army Artillery School in Idar Oberstein for use by fighters at ranges of up to 56 miles. The history of the application of the younger HIMARS is no less extensive. In October 2010, they assisted in the Nato offense in Kandahar, hitting the hideouts of Taliban commanders, forcing them to flee to Pakistan. A little later, in November of 2015, the U.S. Army deployed HIMARS in Iraq, firing at least 400 missiles at the Islamic State since the beginning of the summer, and in March 2016, the military fired HIMARS missiles into Syria for the first time in support of Syrian rebels fighting ISIS. Since then, M142s have been regularly moved, and after being based in Jordan in the same 2016, the United States deployed them again near the Turkish-Syrian border, subsequently firing at ISIS once again. HIMARS also took a direct part in the battle for Mosul, and just 2 years later, as a result of effective missile strikes, these MLRS managed to destroy 50 Taliban militants and leaders in Musa Qala in Afghanistan. 3 of the launched missiles hit their building within 14 seconds. And last, but certainly not the least of them, the M142 brought defeat to ISIS in eastern Syria as part of the Deir ez-Zor campaign. At that point, the U.S. military was striking ISIS positions from HIMARS alone with up to 30 missile strikes per day. But the main event, and finest hour for MLRS over the past decade, has been the resistance put up against the invasion of the Russian occupation forces into the territory of Ukraine. Despite multiple concerns about the transfer of American MLRS to the Ukrainian army, the voice of the people still turned out to be louder than the attempts of even the largest EU countries, France and Germany, who tried to dissuade the United States from transferring heavy weapons to Ukraine. The last remaining weeks, leading up to the announcement of the final decision regarding the MLRS, were difficult for the Ukrainian people. Despite the previously signed Lend-Lease, many European politicians continued to play along with the Kremlin, trying to bring Kiev to territorial concessions. But the country is lucky that not only the truth is on its side, but also strong allies such as the US and Great Britain. Since shortly after Joe Biden's decision to transfer a sample batch of 4 M142 HIMARS as part of a $700 million aid package, British Defense Secretary Ben Wallace confirmed the transfer of the M270 MLRS to that country, capable of hitting targets at a distance of up to 50 miles, stating that today the whole world is on Ukraine's side. Highly effective MLRS will certainly assist our Ukrainian friends in protecting themselves from the Russian invaders, who level entire cities with impunity and terrorize civilians with long-range artillery. Today, the fighters of the armed forces of Ukraine are already being trained in the use of American MLRS, and before long they will introduce these new toys to the enemy. So what do you think? Will the American MLRS be powerful enough to rid the world of bloodthirsty Russian dictator and his ilk? Share your guesses in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell so you never miss out on more videos just like today's. Thank you, and we'll see you in the next one.
Rocket artillery is one of the most destructive weapons on the modern battlefield. The M142 HIMARS has recently become the main hitter in this class of weapons, allowing the Ukrainian soldiers to foil the plans made by Russian insane dictators, pushing back the army that he's boasted so much about. In today's video, we're going to be updating you on how much the situation at the front has improved, at least after the appearance of the HIMARS, and whether the ATACMS will be able to change the course of the war. HIMARSs are mobile, multiple-launch rocket systems which were developed for the U.S. Army back in the 1990s and have since taken in part in virtually every high-intensity conflict in recent decades. By design, they're extremely similar to their older brother, the M270 MLRS, except for the fact that the M142 is mounted on the frame of one of 5 front FMTVs, or the Family of Medium Tactical Vehicles. Instead of a track chassis, this carries a 1 container of 6 GMLRS missiles or 1 ATACMS versus 12 GMLRSs and 2 ATACMSs in the case of the M270. At the same time, the blocks with the ammunition are completely universal, either without any add-ons or with any additional software installed on both MLRSs. By January 2016, according to Lockheed, the HIMARS has completed 1 million hours in the U.S. military, reaching a 99% degree of operational readiness. Although by 2012, several missiles launched from this system successfully destroyed targets in Afghanistan during the Moss Track operation, the purpose of which was to drive the Taliban out of Maraja and eliminate the last stronghold in the Helmand province. And in November 2015, HIMARS was deployed to Iraq, having fired at least 400 missiles at ISIS targets since the early summers of that year. The fight against ISIS using these launchers was only gaining momentum in 2016 when international media and the U.S. State Department had reported that the launchers had worked against Islamic State targets in Syria along the Turkish border. In October 2016, HIMARS was deployed to Quara West Airfield south of Mosul, taking part in the Battle of Mosul, a major military campaign to retake the city from ISIS, having successfully captured it in 2014. A year later, the systems were placed in the Syrian Al-Tanf to support rebel forces in the area. In the year 2018, there was also no less success for the M142 whenever American MLRS had killed 50 militants and Taliban leaders in Musa Aqala, Afghanistan. In just 14 seconds, the building in which they were located was struck by 3 rockets. In that same year, in coordination with the Syrian Democratic Forces, the U.S. military launched up to 30 GMLRS missile strikes against ISIS positions, placing HIMARS in the Omar oil fields north of militant-controlled targets. But the decisive milestones for HIMARS was without a doubt in 2022, whenever Russia treacherously attacked in Ukraine. And now, let's take a look on HIMARS in action in Ukraine. This video was obtained from Ukrainian's YouTube channel United24 Media. Go ahead and click on the card on the top of your screen, and also subscribe and support Ukraine in this cruel war. Let's move on. After the U.S. allocated military assistance containing several dozen M142 MLRSs and more than 10 M270 units, Ukraine's allies have shown no intention of slowing down the pace of supporting adding another 18 HIMARSs from above as part of the new $1.1 billion package. After falling into the capable hands of the Ukrainian armed forces, launchers firing a 200-pound warhead at a distance of 50 miles had completely changed the course and direction of the war, negating Russia's numerical advantage. A retired U.S. Army officer who served as the commander of the U.S. Army Europe pointed out aptly, quote, "You don't need hundreds of artillery shells to achieve the same effect as a single missile fired from HIMARS." U.S. Army General Mark A. Milley, who's chairman of the Joint Chief of Staff, in turn confirmed that the UAF had successfully hit more than 400 Russian targets with just one HIMARS, including command posts and ammunition depots. He also stressed that the Ukrainian soldiers quickly mastered both the M142 and MLRS. These installations allow infantry to deliver insane amounts of fire in just short periods of time, allowing for enemy positions to be destroyed before they leave them. Additionally, successful attacks on command facilities destroyed the Russian supply chains, preventing their leadership from providing logistical support and firing. Just look at what happened to the bridges around Kherson in southern Ukraine. But more importantly, the American MLRS had helped to push the Russian occupying troops from various cities and to liberate dozens of settlements, saving thousands upon hundreds of thousands of lives from peaceful Ukrainians. However, in order for the counteroffensive actions of the United Armed Forces of Ukraine to have a greater effect, they needed to be armed with ATACMSs. The MLRS's family of missiles are effective, but the range ends up becoming a bottleneck when it comes to enemy targets when they are located at a distance of more than 100 miles. This is where the ATACMSs come into play, extending that strike range to several hundred miles. To begin with, let's just call what kind of a beast this is and what advantages that it has. The MGM-140 Army Tactical Missile System, or ATACMS, is surface-to-air missile manufactured by Lockheed Martin, which is one of the largest U.S. defense companies. Development for the ATACMS began back in the 1980s, whenever the U.S. Air Force had intended to replace the MGM-52 Lance with a much similar solid propellant missile with a nuclear as well as a chemical or biological warhead. The project was named Corps Support Weapon System, or CSWS. But the Department of Defense became concerned that the two divisions were developing too many similar missiles with different warheads all at once, and it decided to merge the program with the U.S. Army's Assault Breaker in 1981 with a Conventional Standoff Weapon, or CSW, in 1982. Soon, the new Joint Tactical Mission System, or JTACMS, had encountered resistance from the U.S. Air Force to the idea of creating an air-launched ballistic missile, which is why the service ceased its participation in the non-cruise missiles part of the program, and the project received a new name, ATACMS. March of 1986 was marked by the fact that the LTV had won a contract to develop future missiles designated by the MGM-140. Thanks to the company's earlier experience with previous U.S. military programs, the first test launch of the missiles took place just 2 years later. The quote-unquote debut of missiles was Operation Desert Storm during the Gulf War, during which the U.S. Army had fired 32 missiles from the M270 MLRS. A little while later, during Operation Iraqi Freedom in the Iraq War, the United States used more than 450 missiles. And by 2015, the number of ATACMSs were used by the American Army in combat operations exceeded over 560 units. In order to increase the safety of its creation on the battlefield, protecting it from the watchful eyes of foreign spies and intelligence officers, the United States came up with an excellent, at the same time ingenious solution to apply a pattern of 6 circles on the cover of the ATACMS's launch container. You know, kind of like the standard cover of missiles for the MLRS, HIMARS, and MLRS. So, the enemy never knows which of the blocks contains ATACMSs and not GMLRSs, and simply won't be able to single out one or the other installation as a particularly important target for his allies. Like any other family of missiles, the ATACMS, of course, isn't limited to only one representative and exists in several versions at once. Kicking things off, we have the M39, which is the ATACMS Block 1. This is an integral guidance missile that contains 950 M74 anti-personnel and anti-tank bombs. The range of the application is anywhere from 15 to 102 miles. The U.S. used 32 of these missiles in Operation Desert Storm and another 379 units as part of Iraqi Freedom. This operation is probably the most versatile as it's more suited for all modifications of the M142 and M270 MLRS. Next up, we have the M39A1, also known as the ATACMS Block 1A. This is a GPS-guided munitions carrying 300 M74 anti-personnel and anti-tank bombs. The range of the application goes anywhere from 12 to 186 miles. And along with the basic M39, the 74 M39A1 missiles were used by the U.S. in Operation Iraqi Freedom. However, unlike the M39, the M39A1 mod can only be equipped with the M270A1 or its variants and the M142. Afterwards, we got the M48, or the ATACMS Quick Reaction Unit, or QRU. These are GPS-guided missiles which are equipped with 500 pounds of WDU-18B penetrating high-explosive warheads, which are a part of the U.S. Navy's Harpoon anti-missiles. These were redesigned WAU-23B when used in ATACMS, with a range of anywhere from 43 to 183 miles. The U.S. did fire 16 of these missiles at Iraqi targets during our Iraqi War, and 42 more of these munitions were used during Operation Enduring Freedom. Next up, we have the M57, or the ATACMS TACMS 2000. This one is a GPS-guided munition with the same WAU-23B warhead as its brother, the M48. The range of this guy has a destruction from anywhere from 43 to 183 miles. Finally, and last but not least, the M57E1, or the ATACMS mod, is, in fact, an improved version of the previously mentioned M39 and M39A1 with an improved engine, software, and hardware responsible for navigation and targeting, as well as a WAU-23B warhead, which is installed from the previous use of the M39 series M74 bombs. Additionally, the updated missiles received an advanced sensor for undetermined in the air. Despite all of this power, if the missiles did have a more perfect successor, then one way or another, they would have to make room or even leave the arena. Unfortunately, this did happen to the ATACMS family as well. In 2007, the U.S. Army had terminated the ATACMS program due to cost, depriving the service of the ability to replenish supplies, and had launched the SLEP, or Service Life Extension Program, to maintain the extension arsenal. As part of it, the Army is modernizing and replacing the propulsion and navigation systems, cluster munition warheads with utilitarian high-explosive fragmentation, and also adds a variety of proximity fuse. And although there is no talk of decommissioning them just yet, the United States does intend to complete the program in 2024 with the introduction of the Precision Strike Missile, or PRSM ammunition, which will replace the ATACMSs. One of their main advantages against the background of their predecessor will be the refinement, since instead of one ATACMS in one block, the M270 or M142 will now be able to install two PRSMs. The new missiles will require an improved propulsion system, due to which they'll be able to fly many times faster and farther, reaching the target at a distance of up to 310 miles. But after the U.S. had withdrew from the Intermediate Range Nuclear Forces Treaty in August 2019, it was stated that the range for the new missiles of the MLRS could go beyond the previously announced 310 miles. The appearance of the ATACMS in the armed forces of Ukraine will become that the very long-arm capability of reaching out to Russian invaders anywhere in Ukraine can become a possibility. And that means cutting off the logistics routes of Russians already affected by the successful work of the Ukrainian soldiers. They got bridges, railway stations, and other strategically important objects. The main question now is when and how much Ukraine will receive this ammunition from the United States. Some military experts and analysts state that the ATACMS has already been transferred to Ukrainian soldiers and that it was used during attacks on a military field in Crimea. However, there has been no confirmation from this White House just yet. Although, if you were to look at it from a rational point of view, do you really think the US and Ukraine needs to notify the enemy about the supply of weapons? At the same time, though, almost every transfer of heavy weapons in the US goes through a difficult path from "this is impossible since it can provoke the Third World War" to "this is a complex and long-term process," with the final stage being the first test derivatives of which such weapons that Ukraine would get an observation for the success of their use in the battlefield. So far, the Biden administration has been pursuing a cautious and pragmatic policy, but it's obviously making it clear to Russia that nuclear blackmail will end in a nuclear winter. Not for the Ukrainians, but for the Russians themselves. So, what do you guys think? Will ATACMS be the turn of the war? Let us know in the comments below, and of course, if you enjoyed this video, please leave it a like and subscribe to the channel, as well as hitting that notification bell for more content just like this. Until next time, folks, we'll see you later. Given the realities of the Ukrainian-Russian war, the issue of protecting Ukrainian airspace is an acute one. And thanks to the large number of missiles they have, Russia shells civilian cities and infrastructure with virtual impunity. But very soon, Ukraine will have for itself a setup which is radically changing this situation. And that's exactly what we're going to be talking about in our video today. The Norwegian Advanced Surface-to-Air Missile System, or NASAMS, is a short and medium-range air defense system which was developed in tandem by the Norwegian firm Kongsberg Defense and Aerospace along with the American company Raytheon. Its main targets are primarily aircraft, helicopters, cruise missiles, UAVs, and UCAVs. The development of the system started back in the 1990s, whenever the Norwegian Air Force needed a worthy successor to the US-based Raytheon M23 Hawk anti-aircraft missile system, better known as the Norwegian Adapted Hawk, or NOAA. This ended up being converted by the country according to its own modernization scheme. And unlike its predecessor, the NASAMS is capable of simultaneously tracking and hitting more targets, despite the fact that its operation requires 4 times less maintenance personnel, and the complex's reaction time and transport to and from combat was even greatly reduced. Additionally, let us not forget about the high degree of unification done on NASAMS, thanks to which personnel were able to interface with other advanced weapons. Field tests with the installations were carried out in 1993, and from 1998 onward, the air defense system began to enter service with the Norwegian Air Force, moving into a state of international operational readiness. Ever since the advent of the first generation of NASAMS in service, the system has been continuously developed. Teams of engineers have done a monumental job in modernizing these defensive weapons. By 2000, the air defense systems designers presented an improved modification of NASAMS, known as the NASAM-2, and was put into operation 6 years later. And in 2010, the third generation was finally installed and developed. This time, though, the time to being put into service turned out to be a bit longer, having taken about 9 years. NASAMS do differ from other quote-unquote colleagues at the office, primarily in its net-centric architecture, multiple simultaneous engagements, and BVR, or Beyond Visual Range capabilities, which are closely integrated with other systems and command and control centers of the Norwegian Army. Thus, a network with these air defenses significantly expands the territory they protect, which increases the overall combat effectiveness of the armed forces. The standard NASAMS do have a modular design, consisting of a Fire Distribution Center, or FDC, command post, an AN/MPQ-64F1 Sentinel Active 3D radar, plus advanced passive electronic optional and infrared sensors, and an advanced air-to-missile, the AIM-120 Advanced Medium Range Air-to-Missile, or AR-RAM. Earlier, the traditional air system defense was located at one facility, and this is where the command and control tower was. Weapons and search radars as well as a missile battery were located. But in the case of the NASAMS, the military was given the opportunity to deploy an air defense system over an area of, get this, 7 kilometers and an even greater distance. Due to all of this, the control became possible at a distance of up to 15.5 miles from the control center, making it extremely difficult for hostile forces to detect as well as neutralize such systems. Even if they did manage to hit one or more parts of the NASAMS, the rest will still be able to function. Another distinguishing feature of NASAMS is that it doesn't make use of high radar effects so as to monitor the missile on its trajectory towards the target. This would simply reveal the location of the system itself. Instead, NASAMS have acquired a rotating radar with low effect, which guides the missile initially until its own radar, quote-unquote, takes over. Combined with the latest passive sensors and high mobility, this makes NASAMS virtually irreversible to adversaries. Let's take a closer look now at the air defense component, shall we? The FDC is a time-based BMC-4I, also known as Battle Management Command, Control, Communications, Computers, and Intelligence Control module for air defense and surface-to-surface missiles, or SSMs. It's been an open software and hardware architecture, which does allow you to enable fully netted and distributed operations, as well as introduce new tech and capabilities into the generation of NASAMS. The FDC is the C2 node of the air defense system and provides BMC-4I functionally for any true mixed as well as layered air defense system configuration in national and multinational scenarios. Plus, there's over 200 FDCs to date and have been delivered as a BMC-4I module for the NASAM programs, the Naval Strike Missile Control Defense System, or NSM-DCS, HAWK, and BOCs. The AN-MPS-64 Sentinel is an electronically controlled 3D pulse Doppler radar system which is used to alert and guide short-range air defenses, or SHORAD, to the location of enemy targets. The system is often deployed on a Humvee equipped with an onboard generator, but the radar can also work autonomously, communicating with the fire control center via a broadband fiber optic communication line, along with transmitting data via the SINGSGARS radio network. The Sentinel does support multiple command and control interfaces, providing consistent aerial surveillance data on the approach of enemy air defenses, aircraft, helicopters, and cruise missiles. Nowadays, the U.S. Army and allied forces have deployed more than 300 of these radars around the world, and the NASAMS 2 modification has even received an updated version of the AN-MPQ-64F1 improved Sentinel. Back in October of 2021, the Raytheon Missile and Defense System also introduced a new S-band medium-range AESA radar for air and missile defense, known as Ghost-Eye MR, formerly known as LTAMDS, or Lower Tier Air and Missile Defense Sensor. This announced that it would be installed in NASAMS and be a new modification for the third version. The Ghost-Eye technology itself was originally developed by Raytheon specialists for the M104 Patriot air defense systems, which are fully capable with NASAMS. The AIM-120 AR-RAM is an all-weather American air-to-air missile and the most popular long-range missile in the world. AMRAAM is a continuation of the AIM-7 Sparrow missile series, and for NASAMS has become a replacement for the MEM-23B missiles, which are actually used by the previous generation of air defense, which were in service with Norway until 1998. The AIM-120 turned out to be a lot faster, smaller, and lighter than its predecessors, and also had better performance when working on low-altitude targets. As soon as the missile approaches the target, its active radar instinctively directs to intercept. This feature, known as Fire and Forget, was another advantageous difference between the AMRAAM and Sparrow. In the first generation of NASAMS, the AMRAAM was launched from a towed launcher with 6 missile containers, which had integrated launch rails, which ranges going anywhere from 9 to 25 miles. Shooting the 6 missiles from one launcher is then carried out in a matter of seconds, and by developing a whole battery of 12 such air defense systems, the military can launch 72 missiles within a mere 12 seconds. The U.S. Marine Corps and U.S. Army even tested the launch of the AIM-120 from a 6-rail carrier mounted on the Humvee as part of the CLAWS, or Contemporary Low-Altitude Weapon System, and SLAMRAAM, the Surface-Launched AMRAAM programs. But later, both ended up being canceled due to many budget cuts. A later upgraded Mk2 cluster did end up launching with NASAMS 3 modification and was actually taught to also launch AIM-9X Sidewinder Block 2 and AMRAAM ER short-range missiles with an increased range of up to 31 meters. In March of 2022, Raytheon had also confirmed that in the future, the HELS, also known as high-energy laser weapon systems, could potentially accomplish the rockets in NASAMS, which would be connected to air defense to effectively destroy a swarm of drones. As of 2020, there were 12 NASAM operational in the world, including Spain, the Netherlands, Finland, Australia, Lithuania, Indonesia, and others. Future operations even include Hungary, Qatar, and Taiwan. But the country where NASAMS is virtually needed today is Ukraine, which has bravely repelled the attack of the Russian occupying forces for well over 7 months now. During this time, the invaders have carried out more than 3,500 missile strikes on the territory of Ukraine, with only a minimum of these falling on military targets. Most of these missiles have claimed thousands of civilian lives and do continue to destroy civilian infrastructure. In July of this year, the U.S. had helped its allies with the framework of the Ukrainian Security Assistance Initiative, or USAI, and announced that they would be allocating a military assistance budget of about $820 million, which ended up including 2 NASAM air defense systems, and in August of 2022, they added 6 more just such systems, with $2.98 billion of aid in a package. At the end of July, the Department of Defense announced the start of a formal acquisition of NASAMS to protect Ukraine. This regarded about 2 batteries or 12 mobile launchers with 6 missiles on board. At the end of August this year, it became known that the Pentagon signed a contract with Raytheon for the supply of NASAMS to Ukraine to the tune of about $182 million. The company in turn had confirmed this in an official press release on their website. But what the price of one such installation will be is still a mystery, given that a certain part of the funds will go to the missiles for air defense missiles, the cost of which, the AIM-120D modifications, exceeds well over $1.78 million. We do hope that the air defense transfer process will be concluded before the end of autumn, allowing the civilians of Ukraine to sleep peacefully, knowing that their skies are under reliable protection. So, what do you think? Will NASAMS be able to help Ukraine cut the sky off from Russian evil spirits? Share your thoughts in the comments below, and of course, if you enjoyed this video, please leave a like and subscribe to the channel, ding that notification bell for more content just like this, and until next time folks, we'll see you later.
In order to push back any enemy in today's modern wars, it's important, first of all, to close off the sky via air defense, both for the safety of military personnel and civilians. One of the latest developments in this area is the German IRIS-T. In today's video, we'll be telling you everything we currently know about this air defense system and evaluate how effective it'll be in protecting Ukraine from the Russian invaders. The heart of the IRIS-T air defense system, which has the even longer name of Infrared Imaging System Tail Thrust Vector Controlled, is an infrared homing medium-range air-to-air and ground-to-air missile, the first version of which was put into service back in 2005. Back in the 1980s, NATO countries signed a memorandum of agreement stipulating that the US would take over the development of medium-ranged air-to-air missiles and replace the aging AIM-7 Sparrow. Meanwhile, the UK and Germany would create the successor to the AIM-9 Sidewinder, a short-range air-to-air missile. The American version was called the AIM-120 AMRAAM, while the British-German version was developed under the name AIM-142 ASRAAM. Although during the development of the project, the Germans introduced a new homing head and the British created most of the rest of the components for the missiles, the need for high maneuverability on the projectiles was reduced in favor of their greater range. In the late 1980s, the German Ministry of Defense commissioned the German company IABG, Industrienlagen Betriebsgesellschaft, which specializes in analysis and testing, to study how great the risk there was with 2 aircraft approaching at line-of-sight distance with close airspace monitoring in the presence of powerful radar systems. The researchers found that due to improvements in stealth technology, the presence of a large number of aircraft modifications, and their vast fleet being in different countries, identification capabilities were not able to provide reliable results. Therefore, the pilots had no choice but to fly up to a line-of-sight distance and independently identify the enemy aircraft. Before long, Germany came to the conclusion that the AIM-132 concept was outdated, and in July of 1989 it withdrew from the ASR-AAM project. Britain decided to develop ASR-AAM according to the original requirements, and in late 1990 the US began to modernize the existing AIM-9 Sidewinder design to provide it with increased maneuverability and the characteristics of IRCCM, infrared counter-countermeasures, and the new designation AIM-9X. In 1995, Germany announced the new development of IRIS-T, kicking off in cooperation with Greece, Italy, Norway, Sweden, and Canada. In early 1996, Bodenswerk Device Technology, or BGT, which merged with Diehl Munition System in 2004 and is now known as Diehl BGT Defense, signed a Memorandum of Understanding with partner countries after negotiations with Italy, Sweden, Greece, Norway, and Canada. The new missile was to be installed on the fleet of the European Eurofighter and Tornado fighters, replacing the AIM-9 Sidewinder. At that time, the final list of contractors had not yet been approved, but it was assumed that the Canadian Allied Signal Aerospace would be working on the drives and the Norwegian Raufoss with the engine. Also in 1996, Germany committed itself to about 50% of development costs in excess of $17.2 million, or 26.5 million Deutschmarks. Development was set to begin in 1997, launching missiles into mass production by 2002. By the second half of 1996, Diehl had already completed tests of the layout in the wind tunnel. The missile's dimensions correspond to the Sidewinder, while the wings and tail were already similar to the later production version. The tail section was thickened to accommodate the rudder and thrust vectoring actuators, which increased air resistance. After several test phases on the future rocket, the Dutch Air Force conducted test flights in October 1997 with IRIS-T, for which Lockheed Martin even had to rewrite the F-16 software. In December of 1997, Bundestag gave the green light to IRIS-T to replace the AIM-9L. By that time, Germany had assumed a key role in the program, taking about 46% of the share in it by funding over $325 million, or 500 million Deutschmarks. The second largest participant was Italy with a 20% share, the third was Sweden with 18%, the fourth was Greece with 13%, and the remaining 4% was divided between Canada and Norway. Compared to the AIM-9 Sidewinder, the IRIS-T has improved resistance to electronic countermeasures and glare suppression. Improvements in target identification allowed the projectile to increase the firing range by 5 to 8 times as compared to the AIM-9M modification. IRIS-T can also engage targets behind the launching aircraft. This was made possible by extreme maneuverability at close range, allowing for sharp turns due to thrust vectoring and LOAL, lock-on after launch, capability. The missiles do an excellent job of intercepting and destroying air-to-air, ground-to-air, air-to-ground, ground-to-ground missiles, cruise missiles, and other various small UAVs. To increase the likelihood of a direct hit, engineers also equipped the IRIS-T with an active radar proximity fuse. Additionally, these German Wunderwaffes have the ability to target and shoot down other air-to-air and surface-to-air missiles, thus providing a 360-degree defense capability. But we're currently much more interested in a modification of this missile, which has since turned into a full-blown short-range air defense system, the IRIS-T SLM, the mass production of which began in 2014. It was introduced as part of the Nato MEADS, Medium Extended Air Defense System program, and is now available in 2 versions: IRIS-T SLS Short Range, IRIS-T SLM Medium Range. In the future, another one will also join them, the IRIS-T SLX, which is still under development. Unlike the basic version, the IRIS-T SL ammunition received a more narrow lead with a pointed nose boasting a jettissonable, drag-reducing nose cone. The missiles use an inertial navigation system with GPS and a radar channel for command guidance at the initial stage, while a jam-resistant infrared homing head is activated at the final stage. Another difference from standard IRIS-T ammunition was that of the diameter of the rocket engine increased significantly from 25 to 152 millimeters. The German IRIS-T SLM setup includes the following: a radar with its primary sensor being a 3D AFAR CEA-FAR radar from CEA Technologies, which performs the functions of searching for enemy targets around and preparing the data for aiming missiles at them. It can be supplemented with an electro-optical station, and the developers have noted the possibility of integrating any other multifunctional radar. A control center called the TOC, the Tactical Operations Center, responsible for communication between all components of the missile system via radio or fiber optic cable. IRIS-T SL launcher with 8 vertical firing missiles capable of destroying targets within a 360-degree radius. Due to the quick launch, it's possible to simultaneously fire at several enemy targets at once, taking no more than 15 minutes to reload. At the same time, the launcher is equipped with all the necessary subsystems: an electric generator, a fire control system, a radio station, and others, thanks to which it can be placed at a distance of up to 12.4 miles from the TOC. To increase the efficiency of hitting enemy targets, the IRIS-T SLM missiles received a more powerful engine, due to which their working elevation increased to 82,000 feet, and a flight range is about 25 miles. IRIS-T SL is mounted on either a MAN 8x8 chassis or other vehicles of similar dimensions and carries 8 missiles in containers. The gun design was based on the principle of complete independence from the chassis, so all components are compatible in size and fastening with standard ISO 20-foot containers and can even be transported by ordinary trucks. And thanks to the compatibility of the complex's dimensions with a standard container, the transportation of IRIS-T missiles via aircraft, ships, and other modes of transport has become much easier. Furthermore, the system can be quickly moved using Lockheed C-130 Hercules and Airbus A400M military transport aircraft. If we compare the IRIS-T SLM with the no less sensational Norwegian-American NASAMS project, then with identical operating altitude and range, the IRIS-T SLM may turn out to be even more beneficial in terms of defending certain territory or facilities given the possibility of vertical missile launch. This feature, possessed by German air defense system, eliminates the dead zone funnel that would appear above the complex using missile launches at an angle and reducing the launch time when the target comes from an unexpected direction, since the operators don't have to deploy the launcher. Additionally, the IRIS-T radar, in tandem with Hensoldt's powerful TRML-4D radar, is capable of detecting up to 1,500 targets within a radius of up to 155 miles, versus 47 miles with the NASAMS AN MPQ-64 Sentinel radar. At the same time, let's not forget that NASAMS has a powerful advantage in its ability to destroy ballistic targets, something the IRIS-T SLM cannot boast of with AIM-120 missiles, and has become a well-deserved leader in its class for all U.S. allies. Although because of this, the price of rockets for NASAMS is a much more impressive $700,000 versus the $430,000 for IRIS-T SLM. The reappearance of massive rocket attacks on Ukrainian cities by Russian missiles and Iranian drones once again prompted European countries to speed up the procedure for transferring the latest air defense systems, among which was the first of the 4 IRIS-T SLM systems promised by Germany. Moreover, Ukraine has become one of, if not the first country to adopt this system, since the German defense minister has repeatedly emphasized in her interviews that even the Bundeswehr does not even yet have such a complex. And judging by the recently published photograph of the back of the IRIS-T SLM rocket in the Kiev region, the German air defense system is already being actively used against enemy targets. Ukrainian Defense Minister Alexei Reznikov thanked Germany for military assistance and said that the complexes received by the country mark a new era of missile defense in Ukraine. But there's something that can complement these complexes well, and it's called the Patriot. All that remains is to wait for the moment when the US decides that it's time to pull this ace out of its sleeve. What do you think? How many IRIS-T SLMs are needed to protect the Ukrainian sky? Share your guesses in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content just like today's. Thank you for watching, and we'll see you in the next one.
The successes of the Ukrainian artillerymen have become a key part of the victories won by the armed forces of Ukraine at the front. By cutting off the supply routes for the troops in Kherson, the armed forces of Ukraine forced the Russian Federation to make another goodwill gesture of sorts. Directly involved in this was the spotlight of today's video, the self-propelled Caesar. Today we'll be analyzing this howitzer's principles of operation and tell you all about its usage on the battlefields in Ukraine. Although the prototype for the self-propelled artillery, the British gun carrier Mark I, was adopted as early as 1917, even at the beginning of World War II, almost all artillery was still moved with the help of tractors and horses. Therefore, it wouldn't be an exaggeration to say that most countries developed self-propelled artillery in the midst of hostilities. Early attempts were rather clumsy and consisted of a field or anti-tank gun mounted on a truck. Additionally, unlike modern self-propelled guns, with an impressive layer of armor, their crew remained extremely vulnerable to enemy forces. Modern self-propelled guns are highly computerized and are able to independently monitor firing positions using GPS and advanced inertial navigation systems. Digital fire control, ballistic computers, and advanced communications allow individual self-propelled guns to disperse over a large area, firing at a target simultaneously with other guns in the same battery. And regular upgrades to these self-propelled guns have greatly increased their survivability, thanks to which now these vehicles can evade counter-battery fire much faster and more efficiently. Combined with current logistics systems and capabilities that track and report ammunition consumption and levels, a single gun battery of 6 self-propelled guns firing 495 rounds per minute can deliver more than a ton of ammunition directly onto the enemy's head. Now that we have figured out what a modern SPG is, it's time to take a look at the spotlight of our video. The Caesar is a .52 caliber self-propelled 155mm howitzer, whose formidable name is actually an abbreviation translated from French, meaning a truck equipped with an artillery system. Its main goal is to destroy the enemy's infantry, its artillery batteries, bunkers, as well as to ensure passage through minefields and field obstacles. One of the main enterprises of the French defense industry, Giat Industries, which by that time had not yet changed its name to Nexter, was the responsibility of developing Caesar. Caesar ancestors were the TRF-1 towed howitzer and the AUF-1 self-propelled gun, created by the same company, Giat. By the end of the 1980s, towed guns were noticeably outdated due to their low mobility and a higher probability of being destroyed by enemy counterattack fire. So the military industry within advanced countries paid much more attention to the development of self-propelled guns. But the replacing of the TRF-1 howitzers, in service with the French Army, with brand new AUF-1s began to eat up a significant part of the country's defense budget. And in terms of design, the AUF-1 of the 1970s needed a major overhaul. Therefore, France's leadership, together with its military command, decided to create a new wheeled self-propelled gun capable of hoisting a gun from the TRF-1 and spicing it up with an advanced fire control system. It was also supposed to save additional funds through the use of some of the technical solutions from AUF-1. The prototype for the future Caesar was presented to the public in 1994, and just 4 years later, the prototype gun was successfully tested in the French Army. And although it took another 2 years to deliver the first 5 systems for the Army, in December of 2004, Giat received a contract for 72 Caesar self-propelled guns in order to equip 8 batteries of ground artillery in the French Army, replacing the TRF-1 towed howitzers. Additionally, after a detailed review, the command decided to simply purchase additional Caesars, instead of continuing to seriously upgrade the AUF-1 SP to the improved AUF-2 standard. Caesar was the first mass-produced howitzer based on an automobile chassis. Other countries also attempted to create something similar, but France managed to successfully implement the concept of a powerful howitzer on the chassis of a military truck, combining a relatively small weapon weight with high tactical mobility. The original version of the ACS was created using a towed 155mm TRF-1 on a 6-wheeled Mercedes-Benz Unimog U2450 chassis. But the production version from the French Army received a 6x6 Renault Sherpa 5 chassis with additional armor. At the same time, the country didn't want to limit potential customers to one version. Therefore, it proposed the installation of guns based on other trucks. Modularity then became another advantage of Caesar. After all, thanks to this design principle, in addition to the chassis, the customer can install their own radars, fire control system, initial speed measurements, and completely customize the crew cabin. The artillery part of the setup is a 155mm howitzer with a .52 caliber barrel and can safely be called a universal weapon, at the very least because it's compatible with the entire range of NATO shells, including cluster ones. The ammunition carried consists of 18 shells and varied modifications on the 6x6 wheel setup and 36 shells on the 8x8 version. The installation's rate of fire is 6 rounds per minute, which in conditions of intense fighting is not much less than the maximum rate of the legendary M777, which is 7 rounds per minute. Although, according to some reports, The gun's maximum rate of fire in the latest modifications is up to 8 rounds per minute and 3 rounds in 18 seconds. When using the extended range full bore, or ERFB projectile, the howitzer can destroy targets at a distance of 26 miles. When firing rockets, this figure reaches more than 31 miles. But even despite the Caesar's impressive rate of fire, one of the chips up its sleeve is the ability to quickly gather itself up and exit the firing position. It takes about 2 minutes to fire the same standard 6 rounds and quickly set the howitzer off. At the same time, the gun is very demanding on the crew, and in a normal situation, 5 people are needed to control the system. Still, in critical situations on the battlefield, a crew of 3 soldiers can also handle the gun, as the manufacturer itself has claimed. Here you can, again, compare the howitzer with its ancestor, the 155mm TRF-1, which requires 8 people at once to work effectively on the battlefield. Another advantage of the howitzer's emphasis on mobility is that it can be easily moved using a C-130 Hercules or A-400M military transport aircraft, as well as amphibious assault vessels, service ships, and railway platforms. In addition to the firepower, it's impossible not to mention the advanced computerized fast hit system, which provides automatic fire control, developed by Nexter specialists together with the EADS Defense Electronics team, along with the Intertechnique ROB-4 radar system. The latter is responsible for monitoring the muzzle velocity of the projectile and transmits information to the Matra Defense Equipment's and System CS2002G onboard computer. The computer performs a number of functions, including a 3-dimensional display of the local friend or foe situation, and is responsible for managing the state of the weapons, ammunition, and their timely replenishment. At the Eurosatory 2006 exhibition, the French presented an automated laying system based on the Sigma 30 inertial navigation system, which soon appeared on board the howitzers. One also cannot overlook the degree of safety for the cabin in which the crew is located. The cabin has welded steel armor, providing protection from small arms fire with a caliber of 7.62mm and shell fragments. There's also a temperature control device that informs the crew in a timely manner if the ammunition becomes too hot and there's a danger of being burned. In 2015, at the DSEI exhibition, Nexter introduced a new modification of Caesar, which features an even higher level of mobility due to the improved Tatra T815 chassis with an 8x8 wheel arrangement. The modification was equipped with an unarmored 4-seat forward control cab, which is a 4-control 4-person cab, with the option to install armor, a more powerful engine of 410 horsepower, twice as many shells, and a total weight of 30 tons. This version quickly caught the interest of the Czech Republic and Denmark. Moreover, the latter chose the French gun as the new artillery system of the Royal Danish Army, having purchased 19 howitzers. In February 2002, Nexter received a new contract from the French General Directorate of Armaments to develop a new generation artillery system, Caesar 6x6 Mark II. This one will be equipped with a new chassis sporting a 460 horsepower engine and an improved gearbox, fresh fire control software, as well as a Level 2 mine and ballistic armored cabin. After a 4-year development phase, the Mark II will be put into production. But before that, in 2024, DGA will have to choose whether to start the production of 109 units of the latest Mark II or purchase 33 new self-propelled guns, while modernizing the 76 already in service. Speaking of Caesar's operational exploits, it's worth remembering their deployment to Afghanistan in 2009, when howitzers were sent to support French operations. During the French civil operation in Mali to push Islamic militants out of the north, Caesar was deployed as part of the 68th African Artillery Regiment, and in 2016, French forces used self-propelled guns in the Battle for Mosul, supporting the Iraqi Army's operation to liberate Mosul from ISIS. Although military operations involving Caesar also include the Battle of Baghaz-Fakhani and their use by Saudi Arabia in the war in Yemen, the high point for them has been the war that broke out in February of 2022 between Ukraine and the Russian occupational forces. At the end of April, French President Emmanuel Macron announced the delivery of the first batch of Caesar self-propelled guns to Ukrainian soldiers. And just a month later, the first of these have already scattered the invaders all over the battlefield. Up until November 2022, France had delivered a total of 18 such weapons systems to Ukraine and announced its intention to provide 6 more howitzers by the end of the month. Thus, the armed forces of Ukraine will have at their disposal 24 of the 76 howitzers available to the French army, a quarter of all French mobile artillery. And now it's your turn to share your opinion on the Caesar. Do you think these howitzers have enough power to compete with the M109 Paladin or the M777? Share your thoughts in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.